Yes, ma'am. The 5 minutes, ma'am.
Okay, sir, no problem. Yes.
Ritika Sri,
Yes, sir.
we start the session, ma'am.
Okay. A very good morning to one and all present over here. We welcome you all for the Department of ECE organizing 5 days faculty development program on Internet of Things for technical application. Here comes Selvi M. Kartika of 3rd year ECE department to give the guest intro.
Good morning to Mrs. A. Punitha, Assistant Professor, SRG, Department of Artificial Intelligence and Data Science, KPR Institute of Engineering and Technology, Coimbatore. Mrs. A. Punitha is an accomplished academic and researcher currently serving as an Assistant Professor Junior Grade at KPR Institute of Engineering and Technology since June 19, 2023. Prior to this, she worked as an Assistant Professor at Coimbatore Institute of Technology from June 1, 2012 to June 16, 2023. She had nearly 12 years of experience in academic field. Mrs. A. Punitha is pursuing a PhD in cybersecurity. She holds a Master of Engineering in Computer Science and Engineering with first class and a Bachelor of Engineering in the same field with first class with distinction. She had received a grant of 50,000 from the Science and Engineering Research Board to organize a faculty development program on security informatics and privacy research challenges in the deployment of cyber physical systems in biomedical applications 2024. Mrs. A. Punitha holds several patents, including a blockchain model to improve the reliability of vehicle charging points, an AI and IoT based applied manpower safety controller for MSMES, and a music playing system for smart sensing of the listener mind state. Her publications include significant contributions to the fields of cybersecurity and machine learning, and has presented her work at numerous international conferences.
Thank you for the wonderful introduction, Kartika. Next, the session starts with the chief guest.
Thank you, Kartika, for the wonderful introduction. So, let me share my screen. Is my screen visible?
Yes, ma'am.
Am I audible?
Yes, ma'am.
Yes. Thank you so much for the introduction. So, good morning, everyone. So, myself, Punitha, working as Assistant Professor in the Department of Artificial Intelligence and Data Science, KPR Institute of Engineering and Technology, Coimbatore. First, I would like to thank MPNMJ for inviting me as a part of this 5 days faculty development program on Internet of Things for emerging technical applications organized by the Department of Electronics and Communication Engineering. Without further delay, I welcome you all for the session on the transformative role of artificial intelligence in the Internet of Things. As we navigate through the era of digitalization, IoT has become an integral part of our daily life, generating a vast amount of data. AI is the key to unlock the true potential of this data, enabling a smarter, more efficient, and automated decision-making process. Today, we will explore the symbiotic relationship between AI and IoT, discussing how AI-powered analytics, machine learning, and cognitive computing are revolutionizing industries and transforming the ways we live and work. So let us dive into the exciting world of AI-driven IoT and discover its limitless possibilities. So this is my agenda. Today I'm planning to discuss on AI and IoT, scary rate of IoT data growth, why coupling IoT and AI is much more important, and the areas AI can be applied to, challenges facing when coupling AI and IoT, AI in the efficient implementation of IoT, machine learning, and three generative AIoT applications, and definitely the rise of industrial AI plus AIoT. So AI and IoT is a powerful combination. Artificial intelligence and IoT are the two most transformative technologies of our time. When they combine, they create a very powerful synergy that enhances the capabilities and of the connected devices, which enables smarter, more efficient systems that can learn, adapt, and respond in real time. So, which is much more challenging nowadays. So, a scary rate of IoT data growth. Nowadays, in the digitalization era, the enormous growth of data is happening, and it is supposed to handle with very much efficiency. The Internet of Things is covering the gamut of industries in the areas of healthcare, aviation, automotive industries, predictive maintenance, and many more. So in these areas, or in the relevant areas, the efficiency of the data growth has to be handled with care. So that is why coupling of IoT and AI is very much important. So this is just a diagram depicting the coupling of IoT and AI. Coupling these two domains transforms the raw data into a meaningful insights, enabling the smart automation, enhances the efficiency, and unlocks the new possibilities across its various industries. This integration is a key for creating intelligence and responsive and definitely the adaptive systems that can operate autonomously, learn from the environment, and improve over time. So these are some of the benefits in coupling. So first benefits is the data analysis. So in terms of data analysis, AI can process and analyze vast amount of IoT data, extracting valuable insights. And pattern recognition, in terms of pattern recognition, AI identifies the patterns and the anomalies and the trends of IoT data, which definitely enhances the predictive maintenance, so that pattern enhancing happening much more in an efficiently. And in terms of the automation, AI-driven automation optimizes IoT device performance, which reduces the manual intervention. And real-time decision making, AI process IoT data in a real time, enabling the kind of shifted decision making process, so that the real-time decision can be taken within a fraction of time. And in terms of the improved security, AI-powered analytics detect a huge kind of potential security threats, and definitely it will identify the security threats in the IoT devices, so that the improved security can be given to any kind of IoT coupling systems with AI technology. Enhanced efficiency. This AI optimizes the IoT systems, reduces energy consumption and cost definitely. And in terms of the personalization, AI-driven IoT solution definitely offer a tailored solution experiences. And in terms of the scalability, AI handles growing of IoT data volumes, which definitely enables the seamless scalability benefits. And this is just a statistics says that what the public can understand in AI is 72% of the people just know the knowledge on what AI is, and 70% of the population definitely doesn't have any awareness of what artificial intelligence is, and 11% is not sure on what artificial intelligence. Actually, this is the statistics made by the PECA institutions, so where they clearly depict how artificial intelligence is distributed among the public. So this overall statistics essay, so the individual enterprises have their own stories about the data growth and how they intend to handle it. But surely this is what cloud computing in all forms is all about. But simply processing it. But as of the terms of cloud computing concern, it is simply processing it, transmitting it, and storing it is not definitely enough. So because data is simply not the water or electricity, it is definitely the core assets of the company. So the security and how the efficiency can be handled in the data is pretty much important. So for that, this AI describes how the data can be handled very efficiently. In terms of AI capabilities today, AI has the ability to learn itself and solve problems and interrupt speech and the ability to replicate human interaction, and definitely can able to think logically. And AI capabilities progressively increasing in the field of playing games, run surveillance on the people, and replace the human jobs. And in terms of the AI capabilities, unlikely in the near future, it definitely take over the world and it changes the human mind. It think like the humans. The areas that can be applied to is data preparation. Starting from the data preparation, this is definitely the initial phase where raw data can be collected from the IoT devices, and it is very much clean and organized and transformed to a useful format. It involves the kind of data wrangling, normalization, and ensuring the data quality. Next is the data discovery. So first, after cleaning the data, so data discovery is pretty much important, because in this stage, patterns, trends, and if any kind of anomalies within the data are identified perfectly. This involves exploring the data to uncover hidden insights and establishes relationship between the various data points could be discovered very efficiently. And after the process of data discoveries, visualization of the streaming data or the filtered data is done. This involves creating a kind of real-time visual representation of a data, and it is being generated by the IoT devices. So some kind of visualization, say, that could include the dashboards, charts, graphs. So that can able to understand the data and the data flow completely, what kind of actionable insights I can able to visualize. So that kind of streamlining process can be done with visualization and streamlining data. And next is the time series accuracy of the data, where at this stage focuses on ensuring the a kind of accuracy and reliability of the time series data, which is crucial for making precise prediction and understanding the trends over the time. And also it involves the validating of the data against the expected patterns, and if any deviations to be corrected in this at this particular stage, that could be done. And after this stage, the predictive and advanced analytics is done. In this phase, applying the advanced AI algorithm. So definitely at this stage is very much important, because the advanced AI algorithm is applied in this stage, so that a model can be developed to predict the future trends, behaviors based on the historical data. It also includes the techniques like machine learning, forecasting, and statistical analysis to derive some kind of predictive insights. Some kind of predictive insights I can gather by applying the knowledge of machine learning, And the final stage is the real-time geospatial and location. This obviously provides the location-based insights and real-time analytics. This particularly useful in IoT applications for tracking, monitoring, and managing the assets, etc. And these are the challenges facing AI in IoT. In terms of the compatibility, IoT is a collection of many parts of the systems, fundamentally in the different terms of time and space. And next is in terms of the complexity, with in terms of the complexity with multiple moving parts and non-stop streaming of data, IoT has to definitely provide these solutions with some sophisticated effects. So in terms of the challenges, the coupling of IoT and AI makes a difficult task. And next is the privacy, security, and safety. This is this combination is always an issue in every new technology or a concepts that we focus on. So definitely this privacy has to be a major challenge in this. And in terms of the ethical and the legal issues, for example, if any kind of untested or unethical kind of territory is available with any new labels or the data, so definitely it could be legal issues. And in terms of the artificial stupidity, so back to very simple concept of garbage in and garbage out, AI still needs training, definitely, to understand human reactions or emotions or the decision that could sense from the environment. AI is still evolving. So these are some of the major challenges facing when coupling AI and IoT. And this definitely artificial intelligence will help with the development and the implementation of the data in terms of decreasing the cost of CPU, memory, and storage, converging of IoT and operational technology, advent of big data or cloud or fog, increasing device proliferation, decreasing cost or megabit per second, increasing the VC speed and the investment. So because these kind of sensor deliver data, but data can be valuable if it is means something important and it is actionable. So this IoT and AI go hand in hand for determining how to use those kind of data in very useful ways. IoT can inform AI, and AI bring context and kind of creativity to create an informed action. So always the data should be valuable if it is something important. So these are the broader category of the artificial intelligence, and artificial intelligence do have so many subsets. In this session, I mainly try to focus on these machine learning, because in the past 3 days you were exploring lot about the IoT and some kind of IoT related applications. So I'm here to discuss mainly on the machine learning techniques, because machine learning provides so many logics so that can perfectly couple artificial intelligence with IoT. So so here I mainly discuss on what are all the logics provided by machine learning or deep learning or generative AI. So I think that could be very useful to you. So just in a guess, artificial intelligence is the evolving technique that equip computers to emulate human behavior, enabling them to learn, make decisions, recognize patterns. And machine learning is a subset of AI which uses advanced algorithms to detect patterns in large data sets, allowing machines to learn and adapt. This machine learning algorithms uses both a kind of supervised or unsupervised learning methods. So what are all the logic behind it, I'll discuss in the later slide. And deep learning is a subset of machine learning which uses the neural network concept for in depth of data processing and data analytics. So this deep learning leverages multiple layers of artificial neural networks to extract the high level of features from raw input data, simulating the human brains perceive and understand the environment. And generative AI, which is a booming thing now. So it is a subset of deep learning model that generates content like text, image, or code based on provided input. So trained on vast data sets, these models detect patterns and create output without explicit instruction, using a mix of supervised and unsupervised learning. And this, I want to make a note that this generative AI is mainly focused on the prompt which the user is giving. And generative AI model, the thing we are using now called ChatGPT, Gemini, and the Meta AI in WhatsApp. So all those is being developed with the generative AI. In the generative AI, especially the large language model is being used so that the response between the user and the system makes very easy. It understands the human inputs and it delivers the output within fraction of a second. And I'm here to mainly discuss on machine learning, so especially supervised learning and unsupervised learning. So machine learning is how, so in terms of machine learning here, I'm about to discuss what are all the logics or the algorithm that machine learning is provided, so that when I try to couple with IoT devices, it makes a perfect combination to handle the data very efficiently. So machine learning is how the computer system develops its intelligence. With machine learning, cyber security system can analyze patterns and learn from them to help prevent similar attacks and response to changing behavior. So in terms of the classical machine learning, we have only two. We had actually only two called supervised learning and unsupervised learning. Supervised learning is a task-driven and unsupervised is a data-driven, where in supervised learning, you do have perfect labels available, and in unsupervised learning you don't have any perfect label. So only through the predictions we can able to guess with trial and error method. The classifications of the supervised learning is about the categories of supervised learning is classification, regression, and the classification of unsupervised learning is clustering, association, dimensionality, reduction. Now, this supervised learning is almost all about prediction and predictive models, and this unsupervised learning is some kind of pattern or structure recognition by means of the trial and error method, because we don't have any perfect label to identify it. And this is a Google resource. So in the modern machine learning, an extra type added is called the reinforcement learning. So let us discuss reinforcement learning too in the later slides. So here in the slides, I have represented some of the algorithms provided in both supervised learning and unsupervised learning. So when I try to couple this machine learning with IoT by means of any of these algorithms, so I can able to perfectly handle the large growth of data. So classification, the algorithms provided in the classification is logistic regression, naive-based, k-nearest, support vector machine. And in regression is linear regression, ridge regression, ordinary least squares regression, stepwise regression. Anyhow, we'll discuss each and every one in detail. In supervised learning, the clustering categories into k-means, k-median, hierarchical clustering, and the expected maximization. And the association analysis is a priori, ECLAC, FP growth, dimensionality prediction, feature extraction, and feature selection. In reinforcement learning, it is totally different from supervised and unsupervised learning, a model-free learning and model-based learning. So let us have a brief intro on each and every algorithms provided in the machine learning. So first we go up with the classification. Classification is something like the systematic arrangement in groups or the categories. Systematic arrangement in the groups or the categories. The classification will tell you whether the particular thing is present or not. It will tell you only the true or false category. There are the categories in the classifications of the logistic regression model. As of the logistic regression model, it estimates the probability of an event to be occurring is true or false. So as if depicted in the figure, so the based on the input, I'm supposed to guess whether the penguin is happy or sad. So only depends on the weightage and the input nodes and try to classify it whether it is true or false. So next is the support vector machine. So support vector mission, which uses the classification algorithm for two groups of the classification problems. An optimal plane is drawn between two clusters. So the maximized margin is calculated here so that the similarity between the two different clusters is identified here. So here, next is the k-nearest. K-nearest, which stores all the available data and classifies the new data based on the similarity of the clusters. Next is the regression. So regression, which based on the past inputs, the predictions are done. So it holds the historical information about some kind of particular region. Depends on that, some output could be generated. So for example, weather will be what will be the temperature tomorrow. So if I want to answer from that for that prompt, so definitely I have to have a previous knowledge about the histories of the temperature, what is all about today. So with that prediction, I can able to make for the decisions about the next minute or in the later day. So the classification involved in the regression or the linear regression. So linear regression is a kind like the relationship between the scalar response and one or more explanatory variable are done. So a line of regression is drawn between a dependent variable or the independent variable, or the both x-axis and y-axis could be anything. So depends on the attribute what we are choosing. So the line of regression is drawn between two variables so that the data, the closer to the line of regression is considered to be a valid point, and some kind of dimensionality reduction is done in the points to perfectly identify the data. And next thing is the edge regression. In terms of the edge regression, the singularities between the differential hyperplane is being mapped as depicted in the picture. There could be a center of plane is being mapped based on the different plots, so that the plots which is very near to this point could be gathered for the analysis. So which tells you exactly what could be the output for that. So a line of edge regression could be drawn between the different kind of mapping. And next is the stepwise regression. It builds a model by adding or removing the predictor variable, which the variables or the data points which is not necessary to build a model, that could be eliminated so that I can get some fulfill data inside my table, so that it could be very easy for the analysis purpose. And next thing is the ordinary least square regression. It minimizes the sum of squared vertical distances. For example, here too, I'm going to plot a line between a dependent variable and independent variable. So some kind of common patterns could be identified in the points. So if I try to draw a line between the plots, so I can able to crisp my data so that analysis could be done easily. And next is the unsupervised learning. As we discussed, in unsupervised learning, we don't have any perfect labels. Only through means of the trial and error method, I could able to identify the patterns. So first thing is the clustering. Clustering, which divides the population or data points into number of groups based on the similarities. So the classification involved in the clustering or the expected maximization, which is the iterative method to find the local maxima. So where in this particular type of algorithm, I do have so many iterations I want to make the data points very clear, and it is very easy to visualize. So next thing is the hierarchical clustering. So in hierarchical clustering, there are two: k-means clustering and hierarchical cluster. In k-means cluster, it partitions the n observation into k clusters, and in hierarchical cluster, it builds the hierarchical of the cluster. Whichever data points comes in, whichever plots, then that gets hierarchically mapped. And next thing is the k-median, which clusters centroid to the position of the vector. And next comes the association analysis. Association analysis is the task of finding interesting relationship in the large data sets. The type of the association, so as represented in the figure, the task, so there are so many figures do shuffled here that gets mapped into a plot called a bird or a tree, or so some kind of images being distributed or shuffled randomly. So my task is to find the co-location patterns for the following data sets. So my by considering the global co-location, so I try to co-locate the whole data set. So this is what a kind of association analysis is. And the different kinds of association analysis is the a priori algorithm. A priori algorithm, we might all, everyone aware of the, we always used to get the relevant ad based on our search in the Google. So the reason behind is this a priori algorithm. So relevant information according to the user gets analyzed and displayed to it. So that is the a priori algorithm. And ECLAT is the equivalence class clustering and bottom-up lattice traversal, which is nothing but regroups frequent item set mining. For example, if a person is coming to buy bread, so there must be a possibility of that particular person to get a jam or a butter. So consider in an example for the product store, see the updation of the relevant product or the suggestion about the relevant products can be given with this exact kind of logic. And next thing is the frequent pattern mining. This is also exactly the same as ECLAT, but extracting the frequent item set by means of the threshold. So even though I have, even though a person will buy bread and butter, so a kind of threshold will be set to a particular product or whatsoever your attribute is, they will be setting a threshold level. So if that threshold level is meet, so then some kind of precise information or some kind of clarity about the information is given by this frequent pattern algorithm. And next classification is the dimensionality detection. So this is very, very important. The transformation of data from a high dimensional space into a low dimensional space, because whatever the things we are having now, for example, if I want to test a hardware or a software or any kind of software,
Excuse me, ma'am. Ma'am, are you here? Ma'am, your voice is not audible, ma'am.
Ma'am, you need to unmute, I think.
Sir, am I audible now?
Yes, ma'am.
So far, I've explained the things. Is it audible to you participants? Yes.
Ma'am, it would be better from previous slide.
So from the so far I have discussed, was it audible, ma'am?
Yes, ma'am. It's not audible.
Yes, ma'am. Yes, ma'am. Yes. Thank you so much.
Thank you, ma'am. Yeah, from this.
Yeah, from this. Yes, ma'am. Thank you so much, ma'am. So unsupervised learning. So this is very much important because in unsupervised learning, dimensionality reduction plays a very important role, because the transformation of data from high dimensional space into a low dimensional space is done accurately. Because for every application, either in the hardware or the software, so I need to unpack the attributes present in the software. So unpack that. If I try to unpack that, I can able to gain the one-dimensional information, so that data visualization can be done very accurately. If there is any flaw in that, whether the data are perfect or if any data has to be clean, so that could be perfectly visualized in terms of this dimensionality reduction. So in dimensionality reduction, there are two types: feature extraction and feature selection. So this feature extraction, which transforms the raw data into the numerical features that can be processed while preserving the information in the original data sets. And in the feature selection, which reduces the number of the input variables while developing the predictive model, because selecting the best subset from the set of all features is very much important. So this kind of dimensionality reduction, especially this feature extraction and feature selection, plays a very crucial role. And next thing is the reinforcement learning, which is completely different from supervised or unsupervised learning. So because the agent is learning itself from the environment. So based on the reward points from the environment, the agent tries to learn itself. So this is how intelligent agent ought to take actions in an environment in order to maximize the notion of the cumulative reward. So for example, if I prompt something to the environment, so if the environment accepts, and if the agent receives the award, so the agent tries to learn itself, okay, this is the better output to get generated to the environment. So depends on the reward system between the agent and the environment, this kind of reinforcement learning is happening. So the classification of the reinforcement learning is the model-based and the model-free approach. In the model-based learning, which relies on the formation of the internal model of the environments to maximize the rewards. So especially this model-based learning, which relies on the internal information. This model-free learning is simply the reinforcement learning process, which the values associated with the actions. So based on the action, if I do get any rewards from the environment, I take it in a positive way, and agent will learn itself to better produce the accuracy of the results. So this is the kind of reinforcement learning. And so that's it about the machine. So I think I have covered almost the logics given in the machine learning thing. So when I try to couple this algorithm with IoT, I can able to better create an intelligent agent. So that is why I've discussed some machine learning logics. And beyond the machine learning and the deep learning, the generative AI plays a crucial role. So because the ChatGPT, GenAI, and the Meta AI, everything works on this generative AI. So if that gets applied to the IoT technology, how could be the world is? The IoT analytics is a site which discovers the three generative AI OT applications. So mainly the three generative AI applications, so which is currently booming now. The code generation for IoT. So which is so as I mentioned before, the generative AI application is mainly working on the large language model, which uses the transformers because based on the prompt given by the user, the machine is learning itself to produce the higher accuracy of the results. So the currently booming one is the large language model. So that can be used to create complete or combine IoT code sourced from code snippets or natural language description. And it also learns the natural language processing, because for a machine, it is very difficult to learn the human mind. So if something is mimicking the human mind, definitely the agent will conquer the world. So that is what the world is, the goal of the world to be, to mimic the human mind. So for that, the generative AI helps really a lot. And the second generative AI OT application is the robot control. So this generative AI can be used to generate controls and commands for IoT connected robots by capturing the motion data from animals or humans. So that if I can able to capture the real kind of information or the gestures or the postures or the verbal or non-verbal activities from the environment, the robot can able to perfectly learn itself, so that I can feed to a intelligent agent, which is nothing but a robot. So next generative AIoT application is the social IoT devices, where it can be used to change the interaction with devices. So devices, for example, could provide the users with answer to the complexity. So whatever the complex prompt which I'm raising to the machine, so that has to produce the output with the fraction of the seconds. So this is what the three main generative AI application which is booming now. And next is the rise of the industrial AI plus AI IoT. So definitely the rise of these two vast technology is based on the availability of the new software tools, definitely, because the number of AI software vendors has been doubled more. They are developing enormous amount of open source applications. So where I get used to, and I can able to learn from it, and I can able to develop my own applications. And next thing is the simplified AI solution, which is a new simplification and management tools such as the Auto ML and MLOps. And next thing is the AI in legacy applications. So AI infusion into legacy software application and legacy use cases. And next is the hardware advances, which improved performance and pay peer use hardware is being the rise now. So the AI chips are improving rapidly in terms of efficiency and speeds, and hardware is instantly available on per usage basis. So here I have listed out, so this is also a Google resource. So here I have listed out some of the AI tools for work. So in terms of chatbots, so now everybody are used to with ChatGPT, Claude, Bing Chat, and for the content generation, especially as of in the digitalization era, the content generation is very much important, because the many social media has developed a so lot. So all those social media is mainly focusing on what is that fruitful content I'm just giving to the world. So with if my content is very fruitful and it is very secure and it is very authenticated one, and it is very trustable one. So such kind of content is definitely recognized by the environment, so that this content generation website is also these AI tools, Jasper, Writer, Notion AI. So these are the content generation AI tools, and for the spreadsheets, numerous meeting recording, personal productivity, audio editing, image generation, slide decks, chat with PDF, and synthetic voices. So these are the some of the AI tools, so which we use for. And finally, I have to end my session with Ahmed Bafna, a quote. Integrating AI into the IoT network is big. So actually, she's a blog writer. So I inspired by this quote. That is why I'm projecting here. Integrating AI into the IoT network is becoming a prerequisite for success in today's IoT-based digital ecosystem. Businesses must move rapidly to identify how they will derive value from combining AI and IoT, or face playing catch up in years to come. They need to combine IoT with rapidly advancing AI technology to simulate intelligent behavior and make well-informed decisions with little or no human intervention. So, coupling of AIT with IoT is definitely a booming technology in the digitalization. So with this note, I have a greeting and for a thank you note for my college, MPNMJ Engineering College, for providing me an opportunity to be a part of this 5 days faculty development program on Internet of Things for emerging technical applications, organized by Department of Electronics and Communication Engineering. And I would like to make a note that I'm a proud alumni of this esteemed institution. I belong to a batch of 2007 to 2011 batch, and my special thanks to Bala sir, so who approached me to handle this session. Thank you so much, sir. And thank you, participants, for patiently listening my session. Thank you all so much. Thank you.
Thank you, ma'am. I would like to extend our heartfelt thanks for gracing us with your presence today. Your insights and contribution have been both enlightening and inspiring. We deeply appreciate the time and effort you have dedicated to sharing your expertise with us. Thank you once again for all of your invaluable presence and remarkable contribution, ma'am. Thank you, ma'am.
Thank you. Thank you so much.
Thank you, man. Thank you so much. It's a valuable session to everyone.
Yes, sir. Thank you so much, sir. Thank you. Thank you.
Thank you, man.
Yes, sir. Thank you so much. Yes, sir. Thank you, participants. Thank you so much for your feedback. Thank you. Sure, ma'am. I'll share you the PPT. Sure, ma'am. I'll share. Thank you so much. Shall I leave, sir?
Yes, ma. Yes, ma. You can leave, ma.
Yes, sir. Thank you so much, sir. Thank you.
Come on, welcome. Thank you. So thank you, participants. Thank you so much. So